So this is an explanation how to set up the UMC3D simulator to run it as a simulator for your own testing, for example. When you start the simulator, this page will appear. It will say invalid hardware lock ID. You don't need to care about that one because it's just because you don't have a hardware ID in your computer. So you just click OK on that one. Now you can see here that all these squares that are colored, they are okay, but the most important one to operate is still a bit gray. To solve that, you need to go into settings. And in here, up on the top here, you have to have information on each of these lines. And the information here is related to these different boxes down here. So already now I have a project that I've called test. If I don't have a project, then I go into projects and I either select one project or I create a new one down here. But now I will use the test project. Sometimes on the simulator it might be called Las Vegas, or you will have this test project. After that, you go to the machine. That's the one here. On the machine, you select an existing one, or you can create a new one. If you create a new one, then you decide which kind of machine it is, and then you can give it an individual name. In this case, I will use the existing grader. I'll just have a quick look at the settings for the grader and the setup for it. On the blade controller, you need to have this one here that is called demo blade controller. It doesn't matter which machine it is, if it's an excavator, dozer, grader, wheel loader, it still has to be the demo solution for it, because these one here are official systems out in the market. But since we don't have an official system connected to the simulator, we need to use the blade controller for it. So pick that one. Then you see here, this is page 1 of 3. So you go for page number 2, and then here you make the definition of where the mast height and the blade height and the blade wear. The default values here are quite often okay to use, so you basically don't need to do anything for the simulator. If it would have been a real machine, of course you need to add the proper dimensions here. Same thing for the antenna location, on what side of the blade it is. Down here you state the width of the blade, and on the other line here you state the distance from the left corner of the blade to the antenna. If you need to change the value, just click the box and the keyboard will appear. So we've been through the blade settings. I go back again and once more. Now I have to go into instruments, and this could be a tricky thing. Here usually you pick the GPS or the total station if it's a real machine, but in this case now, since we're working with a simulator, you need to use a road line demo sensor. When you click that one, sometimes it can appear a name here, but as in this case here there is nothing, so I need to add a sensor. I select the type, which is a road line demo sensor. The name that comes up here is absolutely random, and the same thing here, it doesn't matter which one you use here, you can take any one. If you want to give it a name, do it, or just leave it as it is. I press OK, and on the next page here we have the important thing, because in this window here, up here, there has to be a reference, and this reference is basically an alignment that will generate coordinates to the machine to work in the simulator. If you don't have an alignment here, then the simulator won't work. In my project here, I know that the CL-1 is my center line on the project. So I will use this one to generate coordinates for my machine to work along. I have an update frequency, leave it for 7 Hz, that's okay. The sensor speed you can change depending on what speed you want the machine to move on in the design. I think that 1 meter per second is quite okay because it's a slow approach, a slow speed forward. If you increase it, of course the machine will move faster. The start stationing and the end stationing, that's related to the reference line. And in this case here, I want it to start in station 4035 and I want the calculation to end in 5225. When it starts here and it comes to stationing 5225, it will loop and start over again here. So I will have a machine that will run continuously over the site, but will jump back to the beginning every time I reach the end stationing. In the bottom here, I have a possibility to move the machine or locate the machine sideways in the design or up down. If my alignment, if my alignment that I picked up here, if that one goes in a north to south direction, or south to north, then I can move my machine sideways by changing the offset here, the easting. So if I type in, for example, 3 meters, the machine will move 3 meters sideways. And this is the location of the antenna in relation to the center line. I can also add an offset of the elevation. Since I have a height offset now in my machine in the settings I did, that will locate my blade below the surface. So to compensate for that, I'll type in 3 meters here, for example. I can change it anytime, but if I start with 3 meters, I know that I'll be close to the surface at least. So, important, you need to have a reference here. Back again, and back again. So now you can see I have a positioning sensor called A.LIN, and now I have a 3D line, a 3D TRM already, but if I don't want to use this model, or if I don't have anything here, then I need to go into the surface settings. And here I pick what kind of model I want to compare. In this case I use a terrain model. I have 3 different ones to select, but I will pick the 3DCL.TRM. Up here I can add a preview so I can see the whole design. This is the design I will be working with. In a terrain model there is no chainage or no stationing by itself. So if I want to be able to show my stationing also for the machine, I need to add a center line to this terrain model. To do that, I tick the small box here, and after that I can make a selection, and I'll pick the CL.LIN because I think that's my center line. So now when I go into the run mode, I will have a stationing also. It's not necessary, it's free of choice. So now I have all these fields filled in: test, grader, positioning sensor, reference model, and hydraulic system. So if I now go back to the main window, this one has been colored, and now I can press go and my machine will start working in my design. So this is different ways to this is one way to get the simulator to work. I can now also move the machine sideways in the design here if I want to, and I do that by changing in settings, instruments, the spanner, and down here offset easting. I can go for -3 maybe instead. I'll see what happens in that case. and grade. Now you see my machine has moved sideways to the left. If I zoom out here, oh, there's no stationing on that one. That means I have put the wrong line here. So this is my center line. I will pick another one. Maybe go for that one instead. And grade. Now we'll see if I got a center. Yeah. Now here, this is my center line, and now you can also see that I got a stationing down here. Okay, that was about setting up the simulator to run it. Okay, see you. Bye bye.